Hello everyone. We are Neha Srinidhi Chaganti and Manvita. Our registration numbers are 22B01A0526 and 22B01A0562. We are from 2nd CSCA Sri Vishnu Engineering College for Women, Bhimavaram. We are excited to present our video on the topic Shortest Job First Scheduling Algorithm under the guidance of Dr. M. Prasad Sir, PhD, Associate Professor, Department of CSC, SVCW, Bhimavaram. Make sure not to skip this video ahead if you want a comprehensive understanding of the SJF algorithm, delving into its efficiency and impact. We will be covering all the important details, so stick around for full picture. Let's dive right in.
Coming to the context of the video, we are going to explore one important topic in operating systems, that is shortest job first scheduling algorithm. Before jumping into shortest job first scheduling algorithm, we will just take you through some basics of operating system and terminology. Firstly, what is an operating system? It is defined as a software that manages computer hardware and software. It provides common services for computer programs. Operating systems can be defined as an interface between user and the hardware. It can provide friendly environment to the user so that the user can perform its task in convenient and efficient way. Some examples of operating systems include Apple Mac OS, Microsoft Windows, Google's Android OS, Linux operating system, and Apple iOS, etc. Process. In operating system, a process is an instance of a program in execution. In Unix and some other operating systems, a process is started when a program is initiated. It is close in meaning to task, which the term used in operating systems. Every process has its own process ID. CPU scheduling. CPU scheduling is a process that allows one process to use the CPU while another process is delayed in standby due to unavailability of any resources such as input, output, etc., thus making full use of the CPU. The purpose of CPU scheduling is to make the system more efficient, faster, and fairer. What is meant by process scheduling? Process scheduling is the process of the process manager handling the removal of an active process from the CPU and selecting another process based on a specific strategy. Process scheduling allows the operating system to allocate CPU time for each process. An important reason to use a process scheduling system is that it keeps the CPU busy at all times. Why do we need process scheduling? Resource utilization, responsiveness, prioritization, time sharing, resource allocation, multi-programming. Types of scheduling algorithms. Preemptive, non-preemptive. Preemptive scheduling algorithm. In this preemptive scheduling algorithm, the resources are allocated to the process for a limited amount of time and then taken away, and the process is again placed back in the ready queue if that process still has CPU burst time remaining. That process stays in the ready queue till it gets its next chance to execute. Non-preemptive scheduling algorithm. In this non-preemptive scheduling algorithm, once the resources are allocated to a process, the process holds the CPU till it gets terminated or reaches a waiting state. In that case of non-preemptive scheduling algorithm does not interrupt a process running CPU in the middle of the execution. Instead, it waits till the process completes its CPU burst time and then it can allocate the CPU to another process. Process scheduling algorithms. There are six popular process scheduling algorithms. First come first serve, shortest job first, shortest remaining job first, priority scheduling, round robin, multi-level queue.
I'm Srinidhi and I will be explaining about shortest job first scheduling algorithm. Before really learning SJF, let's know some important and frequently used terms in scheduling. The first is Gantt chart. Generalized Activity Normalization Timetable Gantt chart is a visual representation of a process schedule with their arrival times and burst times. Coming to burst time, it refers to the amount of time taken by a process to complete its execution. Arrival time. It refers to the time at which a process enters the ready queue for execution. Waiting time. The total time a process spends waiting in ready queue before it gets executed by CPU is called waiting time. Waiting time is equal to turnaround time minus burst time. Coming to turnaround time, the total time taken by a process from its submission to system until it completes its execution is called turnaround time. Turnaround time is equal to completion time minus arrival time. The last and final, response time. Response time is the time it takes for a CPU to respond. Often, it is measured from the instance a request is made until the first response is produced. So now coming to the main topic of our video, that is shortest job first scheduling algorithm. The shortest job first scheduling algorithm, simply known as SJF, is a non-preemptive scheduling algorithm that selects the process with the smallest burst time from the ready queue for execution. It is a non-preemptive algorithm because once a process starts executing, it continues until it completes or until a process with shortest burst time arrives. So, this is a small visual representation of how SJF scheduling works. As we can see here, the shortest job always executes first. Here is a simple example where four processes P1, P2, P3, and P4 with their respective arrival times and burst times are given. We are asked to find the average waiting time and average turnaround time. As we can see in the table, the process P1 arrived to ready queue at 1 millisecond and its burst time is 3 milliseconds. The process P2 arrived at 2 milliseconds and its burst time is 4 milliseconds. The process P3 arrived at 1 millisecond, which is same as the process P1, but its burst time is 2 milliseconds only. And P4 arrived at 4 milliseconds and its burst time is also 4 milliseconds. So, according to SJF algorithm, as we have discussed it, the process with the shortest burst times execute first. The first step to be followed in any algorithm is to draw a Gantt chart. For that, at 0 milliseconds, no process are arrived. P1, P3, both processes arrived at same time, that is 1 millisecond. Now comparing the burst times of P1 and P3, the burst time of P3 is less than the burst time of P1. Therefore, the process P3 execute first and its completion time is 3 milliseconds. As it is a non-preemptive algorithm, until it finishes its execution, process P3 is not terminated. Next, P1 is already in the queue and P2 arrived at 2 milliseconds. Now, comparing the burst times of P1 and P2, the burst time of P1 is less than the burst time of P2. Therefore, P1 executes and its completion time will be 6 milliseconds. Next, P4 arrives into ready queue at 4 milliseconds, where P2 is already in the queue. Comparing the burst times of P2 and P4, they are equal. When this situation occurs, the process which came first into ready queue and requested for its execution, that process will be executed first. Here it's P2. So P2 is executed and completion time is 10 milliseconds. Finally, P4 is executed with completion time 14 milliseconds. So that is Gantt chart. Now, as we know the formulae to calculate the turnaround time and waiting time, that is, they are turnaround time is equal to completion time minus arrival time. Waiting time is equal to turnaround time minus burst time. As it is a non-preemptive algorithm, the response time will be same as the waiting time. Tabulating all these values, we can calculate the average waiting time and average turnaround time. So, tabulating all the values we got for the process P1, arrival time is 1 millisecond. Burst time is 3 milliseconds. Completion time is 6 milliseconds. Calculating the turnaround time, which is completion time minus arrival time, that is 5 milliseconds. And waiting time will be turnaround time minus burst time, which is 5 minus 3, 2 milliseconds. And response time will be same as the waiting time, 2 milliseconds. Coming to the process P2, arrival time is 2 milliseconds, burst time is 4 milliseconds, completion time is 10 milliseconds. Turnaround time is completion time minus arrival time, that is 10 minus 2, 8 milliseconds. And waiting time is turnaround time minus burst time, that is 8 minus 4, 4 milliseconds. And response time is also 4 milliseconds. Coming to the process P3, its arrival time is 1 millisecond, burst time is 2 milliseconds, completion time is 3 milliseconds. Coming to the turnaround time, it is completion time minus arrival time 3 minus 1, which is 2 milliseconds. Coming to waiting time, it's turnaround time minus burst time, which is 2 minus 2, obviously 0 milliseconds. And response time, which is equal to waiting time, it's 0 milliseconds for process P3. Coming to the process P4, its arrival time is 4 milliseconds, burst time is also 4 milliseconds, and its completion time is 14 milliseconds. The turnaround time will be completion time minus arrival time, which is 14 minus 4, 10 milliseconds. And waiting time will be at turnaround time minus burst time, which is 10 minus 4, 6 milliseconds. Response time will be also 6 milliseconds. Now, it's the time to calculate the average turnaround time and average waiting time from these values. Now, calculating the average turnaround time, 5 plus 8 plus 2 plus 10, which is 25, divided by 4 gives us 6.25 milliseconds. Average waiting time will be 2 plus 4 plus 0 plus 6, which is equal to 12, divided by 4 equals 3 milliseconds. So, the average turnaround time for this example is 6.25 milliseconds and the average waiting time is 3 milliseconds. Before knowing the advantages of SJF, let's figure out the disadvantages in first come first serve scheduling algorithm, simply known as FCFS. FCFS doesn't consider the burst times or the length of the process, which can lead to inefficient utilization of CPU time. Shorter process might be held up behind longer ones, even if the shorter ones could finish quickly. So, the advantages of SJF is that it reduces the average waiting time. SJF is generally used for long-term scheduling. It is suitable for jobs running in batches where the runtimes are already known for us. Just like a coin has two sides, every algorithm has advantages as well as disadvantages. Coming to the disadvantages of SGF, it requires accurate prediction of burst times, which is often difficult. If a continuous stream of short processes keeps coming in, longer processes might never get a chance to execute, causing them to starve indefinitely. SGF can be highly effective in minimizing the waiting times, but in practical situations, especially where accurate prediction of process burst times is challenging, or when a system deals with a mix of long and short processes, it can have its limitations and challenges. So, wrapping up the video, in shortest job first scheduling, the process with the shortest estimated runtime is executed first, aiming to minimize the average waiting time for processes and optimize overall throughput. It helps in achieving better turnaround times by prioritizing smaller jobs, theoretically reducing the average waiting time for other processes in the queue. However, it can lead to a situation where longer processes suffer from starvation if shorter processes consistently keep entering the queue. I hope this topic, shortest job for scheduling algorithm, is clear. Thank you for watching this video.